This is now the sixth and the last video for the C1 notes. So in this problem it says if the sine of A is 2/5 and the cosine of B is 2/3 and angles A and B are both acute angles, so they're in the first quadrant, find the value of the sine of A plus B. All right, so you would start out and you'd say, well, I know the sine of A plus B is going to be equal to, going back to this formula right here, right, here's the sine of A plus B. So if we just follow this formula, remember cosine, 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 sine, this is a plus, so this stays plus. And so this is going to turn into, when I expand this out, the sine of A times the cosine of B, this is just the formula, plus the cosine of A times the sine of B. All right, now we're going to sub in, all right? But notice that we're not told all the values, so we're going to have to go off to the side and calculate a few of these. So we're told that the sine of A is 2/5 right here, and here's the sine of A, so I can sub in 2/5. And we're told that the cosine of B is 2/3, so I can sub in the 2/3. But when I get to here, I don't know these, all right? I'm not told the cosine of A, and I'm not told the sine of B. So how can we find those? Well, this goes back to things that we did earlier, so I'm going to go down here below. If I know the sine of A, I can find the cosine of A. And I can do that one of two ways. Remember, you can either do it geometrically or you can use the Pythagorean identity. If I do this geometrically, I'm going to go down here. If I know that the sine of theta is equal to 2/5, and I know that this angle is in the first quadrant, so here's my theta right here. Remember, sine is y over r. So if that's y over r, then when I set this up, I could let y equal 2 and r equal 5. So here's my point on the terminal side of my angle. And r is going to be 5. Remember, r is the distance from the origin out to that point. Y is this value right here. So this is the point something 2. And I need to know what x is so that I can find the cosine. So we're going to use the Pythagorean theorem. So we end up with x squared plus 2 squared, which is 4, is equal to 5 squared, which is 25. So x squared is equal to 21. And x is going to be equal to the positive square root of 21 because we're in the first quadrant. And so that means that the cosine of theta is going to be equal to x over r, so it's the square root of 21 over 5. So now we can go back and sub that in, square root of 21 over 5. Now remember that you can also do this with the Pythagorean identity. We know that the sine squared, so this is an alternate way to do this. Remember the Pythagorean identity says sine squared theta plus cosine squared theta is equal to 1. And if I know that the sine is 2/5, then I can sub that in here. And remember that means 2/5 squared plus cosine squared theta is equal to 1. So when I square this, I get 4/25 plus cosine squared theta is equal to 1. I'm going to subtract 4/25 from both sides. So this becomes cosine squared theta is equal to, this is the same as 25/25. So this is 21/25 when I do the subtraction. And now I take the square root of both sides. And remember that when you take the square root, you have to at least consider positive and negative. But again, I'm in the first quadrant, so I only want the positive. So this is going to become cosine of theta is equal to the square root of 21 over the square root of 25. Remember, this is the square root of 21 over the square root of 25. But that's just 5. So we end up with the same answer. All right, so whichever way you prefer, whichever way you think is a little bit easier to do. All right, so we've already got that. All right, so now we need the sine of B. So likewise, I don't know the sine of B, but I do know the cosine of B. So the cosine of B is 2/3. So let's go down here again and do this work. So if the cosine of B is 2/3, and remember again, we're told that this is in the first quadrant. Cosine, remember, is x over r. So our angle would be, again, somewhere like this. So we're going to let x equal 2. And we're going to let r equal 3. Remember, r is the distance from the point, from the radius, from the origin out to the point. And we know the x coordinate is 2. So we need the y coordinate because we need the sine of b. So if we use the Pythagorean theorem on this, then we get y squared plus 4 is equal to 3 squared, which is 9. So y squared is equal to 5. So y is going to be, again, it's the positive square root because we're in the first quadrant. So we know that this is 2 over the square root of 5. And so that means that, therefore, the sine of theta is going to be y over r, which is the square root of 5 over 3. And again, if you like the Pythagorean identity better, you can always use that. I'm not sure why this keeps freezing. Okay, so we're going to come back here, and this is the square root of 5 over 3. So now if we multiply these together, we're going to end up with 4/15 plus, and then remember again, when you multiply the square root of 21 times the square root of 5, you're just going to multiply these together. And so you end up with the square root of 105 over 15, sorry. 5 times 3 is 15. And so this turns into 4 plus the square root of 105, all divided by 15. And that's the final answer.